Welcome to the basics of rigging. I'm CT Stelz and I'm here to demonstrate the capabilities of rigging and being able to use it. First, in order to be able to rig, you need to know the basics. So what I'm going to be talking about in this lesson is the use of constraints and how they're utilized. Constraints can be formed, pieced together, models that are independent from one another. What I've created here is there's this little machine, and as I rotate the controller, it spins everything else. And this is done using primarily constraints and the connection editor. So before you're going to be able to do this, you'll have to learn the basics, especially if you're going to be into character rigging as well, because you'll need constraints that's there. So first I have these models here, and what I'm going to go to is the animation menu set. This is where you'll find all of your rigging controls, and I'm going to go over to constraint. Now these are your main constraints all listed here. The ones I'm going to demonstrate are these four here. I'm not going to be demonstrating scale, but basically each one is you'll have to do it. You'll have to click in a certain order. In order to be based on which order you click will determine on what will be the end result. So if there's two expressions you need to remember. There is child, parent, P, and there is the last thing you select is the one that gets constrained. Now, to demonstrate child, parent, P, basically there's two types of actual influences. There's child's and parents. Parents is the one in which it influences the child. Anything the parent do, the child will replicate. So if I want this to be the parent and this to be the child, I will select the cone. I have to remember my expression, child, parent, P. So I select child for child in the expression, parent, hold shift, click the parent, and then press the P on the keyboard. Now when I move this, the child will go with it. Okay? Basically what you can see what happens here is that it gets grouped. So I'll do that again, child, parent, P, and you'll see it's basically a grouping where it moves the cube under the cone. So I'll just undo that. Now, for the constraints, you need to remember the last thing that is constrained, the last thing you click is the one that's going to be constrained. So in a way, it's kind of a reverse of what I've said. So for child, parent, P, you'll use that for parenting. The second expression, the last thing you click, is the one that will be constrained, you'll use for constraints. So if I want this to be constrained to this, I have to select this last. So to demonstrate the point constraint, I'm going to click the cone, then the square, then click point. And you'll note that the cube moved to the cone as opposed to the cone moved to the cube. Now what the point constraint does is it basically takes what the two pivot points of the objects and makes them on the exact same spot. So in case you don't know what the pivot point is, it's basically the point in which the object rotates or moves or translates or whatever. So this little square here that moves, I can manipulate this pivot point by pressing insert and press V. I can hold down the V and select it to a point on the cone and then press insert again, and I've moved the object's pivot point. So now when I click the cone, then the cube, and then click point constraint, you'll see that this is a different result from this. So what I'm going to do now is I'm just going to kind of go back and edit it. Okay, here we go. It's undooed. Alright, so you'll have to remember that, the second expression for all of these, because they all influence one another. So the point is used to combine the two pivot points. The aim constraint is different. Okay, so I'm going to click I want this to point at or aim at the cube. So I need to select the cube first, and then the cone, because it's going to be the one that's going to be influenced. So I'm going to click constrain and then aim. Now what I'm going to get is I'm going to get this weird thing. Now if you'll notice when I move the cube, the cone rotates. Now I want the cone to actually point at the cube. select the tip, will always be pointing at the cube. And this is actually common. Most of the times you'll have to set what's called the aim constraints and the vectors. Now these vectors here will influence the direction on which this points. So first I'm going to set it to 0, and there's no influence whatsoever. And this is the aim vector located here. So I need to find the right axis, which in this case will be the y-axis, and which will rotate. And most of the time I just kind of guess until I get it right. But if I wanted to, I have to have one set at 1, and the other ones I can just do any number and kind of get a different result. So if you want more precision, you can add additional. Try not to go above 1 though. So now when I move it, you'll notice the cone always points towards the cube. And this is also useful for when you're pointing different directions. So like way over here, I need this pole, the pivot point's located here, and I need it to point towards this object over here. So that's when I would use the aim constraint. Alright, so come back over here. Now this one's a little bit different than parenting. Like I said, there was child, parent, P, which it's pretty straightforward. Child, parent, and P, and you'll notice I get this little connection here. It's saying it's parented. However, with the constrained parent, it's different. So I have to remember my second expression. The last thing selected is the one that gets constrained. So if I want this to be constrained to the square and cube, I'll have to select this last. So I'll select the cube first, and then the cone, go to constrain, and then parent. Now you'll notice I got a little constraint note here instead of the cube actually being parented. Well, the cone being parented under the cube. But here's the cube, here's the cone, and the parent constraint is under the cone. So now when I move the cube, the actual cone is going to move with it. Now this is useful if you're trying to, well, let me just show you. I'll come over here. I'm going to select this, the actual constraint node. And what I have here is I have these weights. Now, typically this is between 1 and 0. And if I have multiple parents, I can move parents between the two. So like, in the case in which I had the child, parent, P, I don't have any weights. So if I had like 3 objects all, and I wanted them all to be parented, and I wanted eventually this one to be parented to the 3rd object, I have to have the weights. So I'll animate, I'll keyframe the weights, and there'll be lots of nodes depending on how many you add. But for the most part, I don't use the parent constraint a lot, but it is a good way to parent something when it's not, when you can't do this. You can't just move it to another location or parent it. The last one's kind of fun. It's not used very often, except for I use it in some character rigging, especially when I'm setting up FK controls, and that's forward kinematics. You'll learn that later on. But basically, if I have this cone, I'll show it with the cone, it's easier. I'll rotate this. Okay. So it's some crazy rotation, and it's edited that way, and I don't want to copy all of this. So what I'll do is I'll select the cone, and then I'll select the cube, and I'll do an orient constraint. And basically what it does is it copies the exact variables that I have over here. And after it has everything that is copied, I can come back to the cube and I can just delete that, and it still retains all the attributes. So this is the most useful during forward kinematics, because you have these controllers, and a lot of times there's these bones at weird angles, so you need to move this controller around the bone itself. For the most part, I don't use the parent or orient constraints for any part of this machine. This machine itself, I've only used was the point constraint and the aim constraint. And I'm going to show you how to rig this in just a few minutes. So stay tuned.